In this problem, we are told that the radius of the cone is increasing at rate of 1 foot per second, and the height of the cone is decreasing at a rate of 2 feet per second. And at certain point of time, the radius is 30 feet and the height is 20 feet. In that situation, we have to determine if the volume of the cone is either increasing or decreasing. So let's answer this question. So first, let's convert the given information into the derivatives notation. I'm going to write down the mathematical symbol of this information, that is the radius of cone is increasing at 1 foot per second. So we know the radius of the cone is denoted by the letter R and height is denoted by H. So we can write this information as dr over dt. Since the radius is changing with respect to time, we write like this, and this is given as 1 foot per second. So we can write down this as 1 foot per second. And when we use this information in our equation, we can substitute only 1 without the units. And then we are also given the height is decreasing. So I'm going to write down this as a dh over dt equals, I put a negative because the height is decreasing. Negative 3 times, I'm sorry, negative 2 feet per second. So I write like this. Now I'm going to utilize the volume formula because we want to know that if the volume is either increasing or decreasing. So considering V as the volume of the cone, the formula says, if you look at this over here, it is 1/3 pi r squared h. So I'm going to copy that formula. I have 1/3 pi r squared h. Now we want to find the rate of change of volume. So let me differentiate with respect to time on both sides. So when I do that, I will get dv over dt equals, this 1/3 pi is a constant. So it remains as it is, 1/3 pi when we use the constant multiple root. And then we have to differentiate only the remaining terms, that is d by dt of r squared h. Let's continue the finding the derivative on the right side. Since we want to find the derivative of r squared h, we can apply the power rule over here. So that is, let me write down this 1/3 pi, and then I keep the one of the variables as constant, multiply with the derivative of the other, plus I keep the other constant as constant and multiply with the derivative of the other. So that is basically the power rule. So suppose if we have the function fx multiplied by gx, the derivative of this is equal to derivative of f of x, that is f prime of x, multiply with g of x plus keep the f of x and then multiply with the derivative of g of x, which is g prime of x. So in the same way we can do it. So first let me find the derivative of r squared, keeping the h as constant. So I multiply with h, then I find the derivative of h and then multiply with the r squared term as it is. So this is going to give us, this will be 1/3 pi, we have the square bracket, derivative of r squared, we can apply the power rule as well as the chain rule. So this is going to result as, when we apply the power rule, we can write down this as 2r because we have the power as 2. So this 2 comes in front and we raise the r to the power of 2 minus 1, which is 1. So I'm just writing this as 2r. Then applying the chain rule, we have to differentiate the r with respect to time, which gives us dr over dt. So basically the derivative of r squared with respect to time is 2r times of dr over dt. So let me write down here, that is 2r dr over dt, and then we have this h as the product. Then similarly we differentiate this h with respect to time. So it's just a single variable h. So derivative of this will be dh over dt, and then we have the r squared term. So we put this r squared. Now we have all the information. We could substitute into the equation over here. So I'm going to take this information, that is dr over dt equal to 1 and dh over dt equal to -2. So let me copy that first here. I think I can clear this. I'm going to first copy those information, that is dr over dt equal to 1. I'm just writing without the units, and dh over dt is -2. Also, we are given the radius and height information. Radius is 30 feet and height is 20 feet. So I put r equal to 20, h equal to, I'm sorry, radius is 30 and height equal to 20. So let me change this. Now I'm going to substitute into this information. So therefore this becomes 1/3 pi. We have the square bracket. 2 times of radius is 30. So I plug in 30 for radius, and dr by dt is 1 multiplied with the h is 20. Then I substitute dh by dt is -2 times of r is 30. So this becomes 30 square. We will simplify this. So this is going to result as 1/3 pi times of 2 times of 30 is 60. 60 times 20 is 1200 minus, because we have -2. This 30 square is 900. 900 times of -2 is -2 1800. So this is what we are getting, and this results in 1200 minus 1800 is -600. So I can write down this as pi by 3 times of -600, and we know that we could simplify this. This is -200. So basically -200 pi. So -200 pi, and we can use the value of pi as approximately 3.14, and when we do that, we are getting the result as -628.32. We have to put the unit as feet cube per second, because we are finding the rate of change of volume. It should be in unit cube over the time. So this is the answer to this question. The volume is decreasing because the final result, we get the volume as a negative quantity. A negative quantity means it is decreasing. So we can mention volume is decreasing at the rate of -628.32 feet cube per second. In fact, we ignored the negative because we already mentioned that it is decreasing. So it is quite understandable. We could ignore this when we give the answer like this.